Example, I'm going to show you the way that you were probably exposed to it, and then I'll show you just the way I explain it. You'll see the process is exactly the same, just the terminology might be a little bit different. All right, so what is the LCD between these two fractions?
Is it x plus y?
Not plus, but just the individual factors x and y. So when you identify that, the first thing you do is find what your LCD is. Remember, it's the things that are being multiplied, so it's every factor of the denominators. In this case, the denominators are monomial factors, so it makes it, again, relatively easy to find. And then you're going to write it as a single fraction. So what most of you probably learned to do was to recreate each individual fraction so that it has the same denominator. So we want the denominators to be xy. So what do we need to multiply the top and bottom of this fraction by? Y over y. That's going to give us our denominator. And then this second fraction we need to multiply by x over x, right? So each case it needs to be a value of 1, the identity property of multiplication, so it doesn't change the value, only the form. And so now when we write this as a single fraction, we get the 5y and the plus 2x, kind of similar to what we did in that first example. And we can now combine the terms of our numerator, which we don't have to, there's no like terms in there, and simplify the rational expression. Again, the only way to simplify this would be to write it in standard form, so the x's are written first, followed by the y's. There's no domain restrictions because no factors were canceled from the denominator, so you're good on that. Pretty relatively familiar with that? You guys have seen that before? And so here's the only distinction between the way that I will do this, is I'll kind of combine these two steps into one. And when I say find the LCD and write it as a single fraction, the way that I would do that is, if I'm given this problem, right away my first step is to write my LCD in the denominator of a single fraction. And then the terminology I'll use is, I'm going to take the numerator of my first fraction, so 5, and I'm going to multiply that by any LCD factors that are missing from its denominator. So looking at this first fraction's denominator, which of these LCD factors are missing from that denominator? The y. Okay, then move to the next fraction's numerator, so plus 2, and I'm going to multiply that by any LCD factors missing from its denominator. So it has a y. What LCD factors is it missing? Just an x. And so now I can just reorder the terms exactly in this step. So it's a little bit less work. I'm not going to rewrite y over y and x over x every time. I'm just going to use that terminology. Was everybody able to follow kind of what I meant by the LCD factors not in the denominator? Okay.